So a lot of times I like to use the prime notation, but we also have to get used to using the dy dx notation. So let's practice a little bit with that notation. For this question, we need to differentiate two different functions. They kind of look the same, but they are different, very different. And I just want to make sure you understand why. So why are these different, first of all, before we even talk about any derivatives? So what you need to know is that this function here means, remember that's an abbreviation for sine x in brackets and then squared after, right? The reason we write the little 2 up here is just to avoid having an extra set of brackets. Whereas this one, what is the difference? If I have some number x, in this question I square x first, get an answer, and then take the sign of that answer. Whereas here it's the opposite. When I'm given that number x, I first take the sign of it, get an answer, and then square the answer. And those are very different operations. And so we should expect the derivatives are different as well. But we will need chain rule for both of these. So let's do dy dx, kind of the same as y prime or f prime of x. So they're all the same, just different ways of writing it. For this one, what is the outermost function here? It's sine, right? So we're kind of ignoring the x squared right now. So this should be, to find the derivative of this, we're going to do cosine of this multiplied by the derivative of that, right? Let's fill that in. And now that we've done that, the rest is easy. The derivative of x squared is the only thing we have left to do, and that's just 2x, right? So cos x squared multiplied by 2x. And it does look better to put that in the front, so that way we get rid of the brackets and it's just a cleaner way of writing it. These brackets here, they're kind of optional. You wouldn't really need to write them, but I think I like putting them there. It gives it makes it a little bit more precise. So that completes that one. Now how about this one? On the last one, the outermost operation was sine, right? But this one, the outermost operation is squaring. So we kind of think of this as something squared. Whereas back here we were thinking of this as sine of something. So the derivative of sine of something is cos of that something times the derivative of that something. Whereas here it's opposite kind of. It's something squared. So to find the derivative of something squared, it's 2 times that something to the power of 1 times the derivative of that something. And let's just fill that in. And now the hard part's over. 2 sine x is just fine the way it is. We don't need those brackets right here. And to finish it off, we just need to do the derivative of sine x, which is cos x. That's perfectly fine for an answer. It is tempting, though. There is a little rule that 2 sine x cos x is actually, it's a little trig identity. It's equal to, one second here. 2 sine x cos x is actually equal to sine 2x. You don't have to write that. Both of these are fine. And this is good too. So whichever version you want to give for your answer, that's fine. The most important thing here is make sure you understand the difference between these two functions. They look a little bit the same, but they're very different. And notice the derivatives are quite different as well.